Hello everyone and welcome back to the channel. In this video, I will show you how to analyze the initial installer of the ICEID malware. We will extract the secondary payload from the ICEID installer, and from that we will extract the initial command and control details. So let's dive in. So here I am in my virtual machine. I have this folder called ICEID. Inside it, I have this folder called ICEID Malware and Artifacts. We will open this folder, and the file that we are going to analyze is the installer DLL. The clear identifier of the installer DLL is that if you look at the exports of this DLL in PE Studio, you will see that it has the DLL register server function. So DLL register server function is here, which means that this is the DLL that we are going to be analyzing, and this is basically the initial installer of the ICEID malware. All right. So in order to analyze this, dynamically analyze this and try to understand what is going on, we are going to have to open it up in x64 DBG. To analyze a DLL in x64 DBG, it is not as straightforward as you might think. For an executable, you just have to drop the executable in x64 DBG, and x64 DBG will take care of the rest. To dynamically analyze a DLL, you have to basically open run DLL32. So I will go to the path of run DLL32, which is c:\\Windows system32 and then run DLL32. All right. After that, I will change the command line. So in the command line, I'm going to, this is the command line which I had already used before during my testing. So I will firstly, I will open up Visual Studio Code and I will paste the command line here in a new document and show you what I mean. So notes.txt, and this is the command line. So view toggle. So this is the file path, and the command line is run DLL32. After that, we have the path of the file, and then we have DLL register server. So we have to change the command line. Go there, change the command line, and paste it here. Once we have done this, we have to select another option, which is in the preferences. We have to select DLL entry. By default, this check is not enabled, so we have to do that and save it. Now, if you press play, basically x64 DBG will stop at the entry point of each and every DLL. So hopefully, all right, so that means that the path is not correct. That's why it did not stop here, and I know why the path is not correct. I forgot to add in the ICEID path, I have to add ICEID. That's it. If I use this, we should be okay. Change the command line. Stop. Open. Run DLL32. Open. Change the command line. Control A, Control V, and we should be good now. First one, second one. So we can see now we have been dropped in this ICEID bin. All right, so here we have to put some breakpoints. The breakpoints that we are going to put is on the virtual alloc function. So let me do that again. Control G and virtual alloc. Go to virtual alloc, press OK. This is basically the pointer to virtual alloc in kernel 32. So we have to press enter again to go to the actual function in kernel base, and here we have to put a breakpoint on return. When the return is executed, the RAX value, since this is an x64 DLL, the RAX will indicate the area of memory which has been mapped for use for this memory, for this allocation. So play, and first time it hits this function, we have a value, we will follow this in dump. So it is now in dump 1. We will hit play again and it will hit this function a second time. So now the value has changed again. We will follow it in dump 2. And we will keep on monitoring dump 1. Play again. And now we see that a next executable is here starting with MZ. This program cannot be run in DOS mode. All right, so we will go and save this, follow in memory map, and then save this, dump memory to file. Go to the desktop, malware, ICEID folder, go to this and save. All right, so now we are done with this part of the analysis. This is basically another DLL which is packed inside the ICEID installer, and we have basically extracted it through dynamic analysis. We can drop this in PE Studio. Actually dropped the file directly. Drop this in PE Studio. And in PE Studio, we will see that this is a DLL. Now, if you go to the export, this is fine. And then when we look at the imports, we can see all the HTTP functions are in clear format. Remember, we are trying to extract the command and control details, initial command and control details, which are embedded in the ICEID installer. So now we are going to use IDA freeware to analyze this DLL and to reach the point where we can extract the command and control details. So go to IDA freeware, right? Open this. All right, so now we are here. In order to simply reach the function where the command and control is happening, we have to just select any of these HTTP functions. So select this, press X to go to the xrefs, which shows that where this function is referenced. And when we press OK, we are dropped in the place of the code where this function is being used. Now, if I press F5, we are going to see the decompilation of the code. And now we can see, by doing this, we can see both of these details side by side. I will do a synchronize with IW. All right, so now we can see that HTTP open is being used, the HTTP connect is being used. Okay, so if you look at the details, for example, if you look at the HTTP connect details, this is the API of Windows which connects to the URL or the website where the connection is required. So it contains 4 parameters here, V8, A1, and A1 plus 24 and 0. Let us look at the API to understand where the link details are present. We can see that the first parameter is the session, the second is the server name. So the second is the server name, and so I can rename this and I can say var underscore possible C2. Yeah. All right. So in fact, let me rename this to var URL. Keep it simple. So var URL, and we can see that when this function is being called, URL is the first variable that is being passed to it. I can rename this function as well, press N, and I can say mw underscore perform C2 communication. It's fine. And then let's look at the xrefs to see where this function is being called and what is the URL being passed to it. So it is being called in 2 places, right? So let's go to the first place. If you go to the first place, the first argument here is basically the URL. So we press N here and we say that var underscore URL. It's fine. And now we see that var underscore URL is basically being set to Amazon AWS here. The first part of the string and the second part is being set to slash. So that's fine. We can keep on going and we will see that there is some further communication going on here as well. Now, if you go inside this function, In fact, yeah, so you can see here that perform C2 communication is here as well inside this function 2314. All right, and v12 is the value. If you look at v12, v12 is created from v19. v19 is created from a1. So a1, and so a1 is the possible URL. So I can say here and var underscore possible var underscore URL. So we go back to where this function was being called, and we look at the first URL that is being passed to it. So it is v25. If you track v25, you will see something interesting. So v25 is being set here. So what is actually happening is that if you look closely, you will see something. v25 is being set in this loop. And this loop is basically starting from 0 going up to hex 20. And for every byte here, it is being XORed with the byte plus 64. And then that value is being set in this variable, which is v25. So it looks like the URL or the command and control details are being generated on the fly, or they are currently encrypted inside the code. So that's fine. And this aws.amazon.com, it looks like this URL is being used to check the connectivity of the system to the internet. So our job firstly is going to be try to understand what is going on here and try to extract the value. And in the future, after we understand how we can extract the value, we can use something like Python to do automation to extract the value directly by pointing the Python extractor to the executable. All right, so point here, and we can see that the location of this code is 180001736. All right, so that is fine. We will use dynamic analysis to step into the code. Firstly, what I want to do is that I want to close this, save it. Okay, I want to change the DLL and disable ASLR in this DLL. So it's very simple. Open the DLL, run dll32.bin, this one, and then go to optional headers, DLL characteristics, click here, DLL can move, press OK. And then I will save it, overwrite. Right. Close this. And now I can open it again in IDA. We will be using basically IDA and x64DBG side by side to analyze what is going on. So the location is 180001736. All right. I will open this DLL now in x64DBG. I'll open the same way as before, run DLL32, and then we have to change the command line. Control A, Control C here, and put this here. And instead of this bin file, we will use this file. So paste it here and use this command to run ICEID. Yeah, play and play, and now we are in the dumped file, right? And here we will go to the point where the extraction is taking place. So Control G, expression to follow, 18000, and then what is the path? 180001736. 1736, and we are here. If you look closely, this is the exact same code that is being used here. So XOR AL RCX plus RDX, byte pointer RBP plus RCX plus 57, whatever. This is the same code here. All right. So we will place a breakpoint on this in this place. And we will also place a breakpoint on this location, which is, if we select this, we can see that the location is 180018BE. You can also press spacebar here and we can see it, 180018BE. So Control G, 180018BE. And go here. This is the call that is made for the command and control. That's fine. We will place it here. Now we will run this and we will most probably hit the first breakpoint. The first breakpoint is hit, and here we can see the command and control C2 information being generated through the XORing operation. So we will go through it once and then I will put some breakpoints and some monitoring, etc. So step over, and step over, and I will monitor this place in the dump. So we can easily monitor what is going on here. So step over. So we can see now the first value has been set. Slowly the second value will be set. Now, since this is a loop, I don't have to go through and press enter on every instruction. So basically I will press play and it will keep on looping, and we can see continuously that the values are being changed. We can see grenade, something is being put here. So grenade meto.uno, and the values are being set still. All right, so now this function, which is the C2 function here, has been hit. This function has been hit, 18,02314. This is the one, 18,02314. All right, and we can see that the value that is being passed to it is grenade meto.uno in the RCX. And we can see some other details that are being passed to it as well. If we go up a bit, we can see that in the RCX, the RBP plus B value is being passed. So RBP is here. Let me follow this in dump. So RBP is pointing to some location, and then the value of RBP plus B is being passed. So it starts obviously from this, and the whole string is being passed starting from grenadeto.uno up till 00. So that is the null pointer. So the whole string is being passed to this method. So now we have an understanding of how this value is being generated. We can also look at what is the initial values that is being used to extract the C2 information. And basically, if we see here, we can clearly identify, let me minimize this. We can clearly identify that this byte is part of the data section here, and it starts from byte 1800005000. All right, so now we have an understanding. In the notes, we can clearly see that it starts from the data section. So C2 value is generated using the value in the data section. I can take out this loop. So this loop is being used, right? But the whole value is not being passed to it. The value that is being used is, if you look here, RBP plus B. So which means that the value of C2 is the start of the character array plus B. So whatever is being generated here, this is the character array, which contains C2, and it will not be the start, it will be the basically start plus the plus B characters forward. All right, so that is fine. Now we can start using Python to basically generate these values, and we are going to use the PE file module inside of Python to help us with the extraction. So extract c2.py. All right, and we can see here import PE file. Import PE file, and the file name that we want to execute, that we want to analyze it, or backslash this. So not backslash this. And now we're going to say PE file is equal to PE file. So DLL file equal to PE file dot PE. And then we're going to give it file. The next thing that we are going to do is that loop through the sections for section in DLL file dot sections. I will show you something how if I don't know what I'm looking for, how I use Python to help me with the analysis. So I will print here, print inside for loop. And after the for loop is finished, I will print here. All right. Now that is fine. Now let me try to run this and put a breakpoint here. Start debugging, Python file. So we've hit this breakpoint, and for section in DLL file dot sections, we want the data section. So how do we identify the data section? We go down and we see that we have two things. Number one is that we have the name here and we have the name here. Now this image section header looks like it is generic, and this name here dot text is the one which we are supposed to use. I will keep on playing, so this statement will keep on getting hit again, and we will see this name getting changed. So play again, and now we're in the BSS section, our data dot data. So this is the place that we need, right? So p data and whatever. So we're done here. So we can say if dot data in section dot name data is equal to section dot. Now I don't know again what are the details that I need. So I will put a breakpoint here again, and I will say print data. I should have checked it before, but that's fine. Part of understanding how we debug something and how we identify something. Run, start debugging. Strange. It is not hitting this point. So let me put a breakpoint here. Start debugging. All right, so we are there. Let's go through and section dot. All right, so name, we made a mistake here. The name in small contains this. We need the name in capital. That's fine. Need the name in capital. We will switch this. And what is the data that is inside this? Where is the data? So is there a data variable or something which will help me fetch the data inside it? So let me try it again. Let me go to the data section actually to see. This is the BSS section, our data and dot data. We are here. So I cannot find anything which is indicative of where the data is being stored as well. So what I'll do is that I will show you another trick on how I try to extract the details. I want to basically try to print all the details which are inside this section. So there could be a function or something which is going to help us with the details. So this could be possibly the function get data. So let's try to use this function. So data is equal to section dot get underscore data, and press this. All right, so we are here now. Let's restart. Start debugging. It's okay. Step over if data in data name dot section. It's fine. First time we run it. And we see a byte like object is required, not an str. So that's fine. We can change this to str here. And run without start debugging. All right. So this time I'm going to press F10 on the keyboard. So we're going to look at this value. It's .r data now. And now it's data. So if it's data, we are inside this function. And if we press F10 again, do we see any value inside data? We can watch this here. All right, so we have this 2 backslash x b5 slash 2 or slash and then 2 and then hash. If we look here, we can see that we have 32 0xb5. So we have 2, which is ASCII 32, and backslash xb5. Then we have slash, then we have 2 again. So then we have slash, then we have 2 again, which is 32. So we are here. We have already reached here. The next thing that we have to do is that we have to run this. All right. So I will convert this in Python as well. So this is extremely easy. So I don't need this. I don't need this. I need data is equal to this. And after this, I will be for I in range if I type 0, 0x20, and we can say extracted. Extracted data is equal to data sorted with data. So this will be data bracket I and data bracket I plus 64. All right. So we are done here with this extraction. And let me comment out this code as well. View and toggle line comment. All right. So this is fine. And we can see that C2 is equal to extracted data bracket colon. The value was RBP plus B. So let's start with B. So we can we say 0xB, and let's see what value we come up with. We can say print C2. Print C2. All right, let's play this. All right, so that's fine. All right, so what does it say? Int object is not subscriptable. What is the value in? All right, so it says that, all right, so what I did was that I made a mistake here. Extracted data is equal to extracted data plus we have to convert this to char and we have to append this to extracted data. I will remove the breakpoint here and I will put it here. Start debugging. It's okay. So play. Now we have to be able to see extracted data here being created. So we see the exact values that we saw, O, M, N or something, which are being set up here. And we can see the value is grenade. So I think it's starting from 0xb, but it's stopping somewhere. Let me start the debugging again and see what's going on. Let's stop here. So if I look at this value, okay, so I made a mistake. It is only fetching 0xb values. In fact, it has to fetch this. So it has to start like this. So if I look at this, what does this give me? It's weird. It starts from B, but does B RBP point to the start of the data structure? Go above. It's RBP plus RCX plus 7. All right. So RBP is starting from here, and the value that we saw being created was from here. So which means that RBP is starting from before it. What we can do is that we can remove all these characters 1, 2, 3, 4, 5, 6, 7. So remove the 7 from here, and if you remove 7, then we should be able to see, for example, let's just say the value should be starting from the 4th location. So let me try again. Start debugging. And now we can see, all right, now we have this here. And in order to extract this string only, we can basically split on the null terminator. So what you can say is that dot split. So the split will happen on the \x 00 character, and we are going to pick out the first part only. All right. So if we put this, we see that we have extracted the link only. So if the C2 is printed, now we have this grenadeto.uno. All right. So now we have an understanding of how we can extract the C2 from the ICEID in basically installer after we've dumped the pat DLL, which is inside the code. So I think we are done for this video. I hope you got a basic understanding of how I use x64DBG and idapro along with Python to help me understand how I can extract the details from this video. I hope you enjoyed this video. I hope to see you in the upcoming videos. Thank you very much.